Hi there, welcome everyone. Thank you for coming along to our talk. I'm Andy Hedges. I work at Tesco, engineering director, so I look after part of our software estate and how we run that. I'd like to introduce you to Adrian.
Hi, I'm Adrian Spender. I'm a head of software development at Tesco, so I own and look after a particular area of our API services called Identity.
So today we wanted to kind of describe how we got to our organizational structure at Tesco. It's been a long journey for us. We've been working on this for about 8 years and just transforming where we are. Along the way, we'll introduce you to some of the concepts that helped us form our views of how we should be structured. But a health warning on this. This is what works for Tesco. Apply it with that in mind. So I'll give you a brief history of where we are and how we got there. So when I joined Tesco about 8 years ago, we were broadly organized around business units, lines of business. So you would have things like the stores business, our grocery home shopping business, Tesco Direct, clothing business, which is called F&F. And they were built over a number of years and broadly duplicate the systems across the piece. So you can see here you've got business A, business B, and so forth. Each one of these has a set of screens, bunch of logic, bunch of data, but they do the same thing. So you've got a product part of it, you've got a price part of it, replicated across systems. And the problem with that was it works all very well in a monolith, you know, if you've got a view on this particular part of the world. But where you want to do a piece of functionality across them, so take, for example, buy a barbecue, get some free burgers and a pack of beer. The trouble with that is our grocery online business, where you get the burger and the beer from, is separate from our direct business. So where you buy the barbecue is different from where you buy the food from. So we'd have to extract a file of all the people who bought barbecues overnight, plumb it into the online, and send them their burgers and beer, which is very difficult. You soon end up in a world where you've got so many of these integrations, so much data flying around between them, that it ceases to make sense. So that was the first thing that struck me as not being right when I joined, something we could improve on. The other thing is we delivered software in a very traditional way. So we'd have business owners, and they would come up with some bright ideas. They would then talk to a business analyst, and they would write down those ideas into a long document. This might sound familiar. Then they would talk to a solution architect as, here's what we want to build. Isn't this great? This is my functional spec. Thud. And the architect would go away, think about it, come up with a design, write another big, long document, hand it to our plucky engineers, and they'll go, that's not going to work, and they'll build something slightly different. As is the way, and the way it should be, really, when you work like this. The engineers would then hand that over to infrastructure, and infrastructure would deploy that onto a set of tin. Once we had the tin in place, and the infrastructure guys would go, well, I'm done with that. Here you go, run. And we'd try and run this thing, support this thing in production. And if you found a bug at that point, good luck to you, because it wasn't coming back. So we took a step back from this, and we said, how should the world look? How do we want our systems to actually look? And we said, well, they should look like things they should look like things that you understand today. So if I were to go and talk to any reasonable person, what would they expect the software to look like? Would they understand what I'm talking about? So getting away from naming systems after Greek gods or planets or three-letter acronyms, we wanted our systems to be very representative of the world. So having things like product and price and stock. But we wanted these teams to be small, so you kind of got these tensions between these big pieces of functionality and wanting small teams. We also wanted to empower our teams, so we wanted autonomous teams. With what I described before, throwing things over the fence each time, you don't empower the teams. They can't make their own decisions. They've got business analysts making a decision on the functionality, solution architect making a decision on the architecture, and that doesn't work so well. So we think empowered teams, people feel more involved in what's happening. We pay these people a lot of money. Let's let them make the decisions that we pay them to make. So getting back to calling things by what they should be. So we got to a place where any reasonable person would understand our systems. We named them after a bunch of things, and I'll talk about how we did that in terms of cohesion. we also decided that those reasonable people should be our customers. We care about our customers first and foremost. So if we went and spoke to one of them, would they understand what we're talking about? And I think with product, price, identity, stock, and then when you talk about internal customers, our colleagues, which we have 460,000 of, they would need to understand these things too. So it might be payroll, it might be tax, if you're an accountant, it might be general ledger again if you're an accountant. But they should be things that are immediately understandable. They shouldn't be called Genesis or Phoenix or TLA or whatever it might be. Breaking them down is really, really, really hard. So we've kind of gone, we've got to solve the problem of being a retailer. It's quite a big problem, and we're quite a big retailer, one of the biggest in the world. So we kind of sort going through this, and what should our services be? And we formed some rules. So there's a couple of things that guided us. A service should be cohesive, so it should belong together, the things that you put in the service, the data and the functionality, by the natural business process that it's representing. So take, for example, a marketing service that sends out email. We call it Contact. That sends out email, sends out Twitter, sends out letters, sends out new club cards, those kind of things. What does that need to know about to do its job? Well, it probably needs to know the email address. It probably needs to know the postal address, perhaps the name, and a number of other things, but not just know the data. You don't go to the system for the data. It needs to have the functionality to do that. So I don't go to Contact, give me an email address, then talk to an SMTP server and send an email. I go to Contact and say, I want to talk to Aaron about this particular thing. And it goes away and works out the best way to talk to Aaron. It goes, well, he likes to be talked to over SMS. So it abstracts that problem away from you. So you get that cohesion between data and functionality. Some stuff that we realized that is an anti-pattern is categorization. So putting all things that are the same together, which is a bit of an OO kind of thought. So these things are all people. So we'll build a people service that has colleagues and customers and suppliers and everyone else we deal with. And that quickly becomes a very large service that needs a huge number of properties on a huge number of things. So it would need address, it would need supplier, how much they're paid, if they're colleagues, how much they bought with us in the past, if they're customers, and it quickly becomes rather large. So big anti-pattern there. Process is another anti-pattern. So say you're building a piece of functionality to register a customer. Registration is a process at Tesco. It's not just saving. It's not a CRUD operation, create customer. It's register customer, which is about storing their name and address and telephone number and all that stuff, but it's also about sending a welcome pack, creating them in our loyalty system club card. So if you build your services around processes, you end up with something that works really well for the registration, but then when you come along to do the marketing thing, oh my God, we need a whole load of other stuff. And you end up with another monolith. Arbitrary, so just sticking stuff together because you happen to be thinking about it at that time. Terrible anti-pattern. Data types, which is what I was talking to really before around the categorization. But data types, let me talk about how you might do it. So say you have a customer concept within your entire enterprise. Some systems need to know different things about customers, so it can exist in both services. It's called a bounded context if you use what Fowler might call it. And within that, so within a marketing system, I'd need to know email address. But within a loyalty system, I might need to know how much you buy baked beans. So you can have customer in both. UUID, so their unique identifier is the same. So I can go, this customer who buys beans is this customer with this email address. But it doesn't have to have the whole customer object in all the services. Temporal coupling, very similar to process. I happen to be using these things at the same time, so I'm going to put them all into the same system. So we broke down all of retail into a number of services, and we organized them in a tree diagram going down in levels of coarseness, if that's a word. So right at the top level, you got Tesco, and you could implement that as one service if you wanted to. It would be huge and monolithic. Don't do that. And then you go down another level, and I've blanked some out because there's intellectual property here, blah, blah, blah. But I've given some examples. So customer, which is the area I look after at Tesco, breaks down into a bunch of services. So identity is one of those. How do you log on? What are your authentication credentials? How do I verify those credentials? How do I manage my session? Is this person who's logged on here the same person who's just jumped across to another application and using this one? That kind of thing, session management. Profile's another service, and that has things like your name, gender, how price sensitive you might be, whether you're a foodie, whether you like the value range, whether you like the finest range, those kind of things, segmentation and so forth. And we broke it down layer by layer by layer, getting more and more fine-grained till you get to a certain point. And Adrian will talk a bit more about that in a bit. Some examples of services, I've talked to these briefly, but let's go into a bit more detail. So product and price is a really interesting one. And first cut at this, we put product and price together. We thought, you're always going to need to know the price of a product. Well, it turns out you don't. When you're inducting a new shirt, we do this very, very far in the future. So it's interesting. I was talking to one of our clothing directors the other day, and he was saying, well, when we're planning a shirt, we go, well, we think white's going to be in fashion. Don't talk to me about fashion, but we think white's going to be in fashion, but we don't know what the weather's going to be like. So we start creating a product and developing it with long sleeves to start with, because it's easier to chop them off and then put them back on again. And that takes a long while, but we don't really need to know the price. And we might have some idea of the price because we might know how much it costs to make them, but it's all very, very, very nebulous at that point. So that sits off on another system called price that's dealing with, is that going to return a sensible amount on the money? And we deal with the product information, what color, long sleeves, short sleeves, but also shipping information too. So they became very separate concepts, and they split apart as we went through it. Price also deals with promotions, so bog off, buy one, get one free for those who don't work in retail, is a price rule. So where I talk about putting functionality in, it's not just the unit price for beans, it's the promotionals around them, pricing up an entire basket of goods. Identity I've talked about, credential validation, session management, payment, storing the cards, PCI DSS, I'm sure a few of you are painfully aware of those kind of things. And then regular payments, it does those kind of things. It allows you to store your card, make a payment in the future. So autonomous teams. We wanted autonomous teams. We feel that they're very important, and they've been a real boon for us because it's allowed us to deliver really quickly and at pace. Everyone doesn't have to do the same thing in order to be successful. So we found some things where they do have to do the same thing. We found some anti-patterns where making them do the same thing wasn't very conducive to delivering the right software for our customers at the right time. I'll give some examples of where doing the same thing is important. So Trace ID. When you call a web page, for example, at Tesco, or a mobile app, it will create a UUID. When it calls a service, it will pass that UUID on. When that service calls a service on behalf of the original service, it will pass the UUID along, and so on and so on. So when we come to debug across 50, 60-odd services, we can see the trace of the entire thing and where it went wrong. It's quite difficult to debug this stuff without it. So we said everyone has to accept a Trace ID and pass it on so that we can do that. Our logging platform's similar, so we use Splunk. Everyone puts their logs into Splunk so we can start to do some analysis across services. Interface definition, so what does the service expose and how does it expose it? The data types, the events that are raised off the service, all in a standard interface definition format, which is OpenAPI spec, so that I can pick up any service at Tesco and go, I get how it works, I understand how it works with my tooling. Requirements management, we use Jira. I can put a dependency on someone else's project and understand when that's going to be delivered. It has a network effect of everyone using the same system. Similar for source control, we use GitHub Enterprise, so I can go into anyone's code base, take a look at how it works and go, you know what, I really need this feature. They don't have time to deliver it in their team. I'm going to go away and code it. I'm going to submit a pull request. They'll review it and pull it in, so we get another network effect. Anti-examples. Making everyone use the same programming language isn't a good idea. We found engineers have, preferences, and hiring is difficult for different types of languages. Some have different characteristics. Some take you down certain paths, some don't. Haskell's a very different language from Java. So we allow people to choose and the team to choose, but that team stays within the same language. We also constrain the number. So I think there's about 5, 6 different programming languages in operation at Tesco, not hundreds, just to keep things a little bit sane. Data store technology, different characteristics for different problems. So identity, which Adrian looks after, has got a very, very kind of high throughput on taking a password and then checking it against a hash version, and that takes you down a certain route for the data store. Whereas others, will use different things. Software engineers picking the laptop they want. So a lot of engineers want to use different laptops. Why force everyone to use the same brand and the same operating system when they don't need to? So what we do is we say you've got a budget. If you want a Mac, buy a Mac. If you want a Linux machine, get a Linux machine. And if you want to use Windows, do that. Was I leaking my bias? Anyway, over to Adrian.
So there are also some fundamental beliefs that we have, and we've arrived at these over time, and none of them are unique to us. But just to reinforce this through the rest of the talk, we believe that monoliths are not the way to deliver and run good software architectures. Hands up if you think they are. Yeah, nobody. Exactly. Whether you want to call the alternative microservices, service-oriented architecture, event-driven architecture, again, we're not biblical about that. But as a principle, small, loosely coupled, well-defined, single responsibility, can rebuild it in a couple of weeks if you want to, is the kind of thing we're looking for. And secondly, Andy alluded to this earlier, we don't believe on throwing things over the wall. Okay, worked in dev, ops problem now is not how we build software. It's not how developers get empathy with our customers if they're 2 steps removed from the problems that the code they write realize in production. So we build it and we run it and we architect it as well. But DevOps for us is very clearly a mindset and a culture. We don't apply the anti-pattern of DevOps being a person or a team. So if we take a step back to the service model, the tree diagram that Andy posted earlier, we can start to now explore this in a bit more detail. So we talked about 3 levels of granularity, and I'm going to give a name to them now. So let's call the 12 kind of broad, coarsely grained areas directorates, because they're typically owned by a director sitting over there. Then we break down one step below that into services. So a directorate typically looks after an aligned set of services, and that service might be delivered by 1 or more teams. So as we go through the rest of this presentation, we're going to dive down into each of those areas, and we're going to look at some foundational principles that has led us to arrive at where we are. And again, I reiterate what Andy said at the beginning, your mileage might vary. Okay, this is how Tesco has evolved our organizational design within technology. You might be different. So let's start at directorates. Directorate is essentially a group of coarse-grained services. So here is customer that Andy looks after, and there are some services within there that are broadly around storing data or providing functionality that's related to the concept of a customer within Tesco. There is a principle that we use to help arrive us at what the size and granularity of a directorate could be, and that principle is called Dunbar's number. Now again, these principles are probably fairly well known. They're not unique to us. We didn't invent them. We certainly didn't discover them. Dunbar's number was arrived at through a guy called Robin Dunbar, and he did a lot of research into the brain, into the neocortex. And he started off looking at apes and primates and was trying to evolve whether there was a pattern between the size of the neocortex and the social grouping that the primates lived in. The kind of prevalent theory at the time was that brain development and brain size grew from complexity of tasks. So, for example, from early hunter-gatherer societies, they would initially start hunting meat, hunting animals, but then evolve to eat fruit, become more vegetarian, and fruit is more complex. You have to peel it, you have to climb up trees to get it, and the theory was that fruit, as we evolved to eat fruit, our brain size evolved. And actually that was proved to be false. And what Dunbar realized that typically brain size evolves with the social grouping that you're in, the complexity of the network that you have to know and understand and have a social relationship with. And he evolved a formula, and when you plug the size of our neocortex in, you arrive roughly at the number. It's actually 148.7, I think, but we round it up to 150. And this number has been proved time and time again. Dunbar actually submitted his paper to the Harvard Business Review, and they promptly rejected it and said, great hypothesis, where's the proof? So he published and be damned elsewhere, and a few years later they essentially validated his theory for him by going off and proving it. I'm sure he found that moment quite pleasing. So, Dunbar's number in practice, one key example of this, which if you've ever read Malcolm Gladwell's Tipping Point, company WL Gore, the company that create Gore-Tex, They take this number so seriously, they actually design their manufacturing facilities with only 150 parking spaces. Okay? When they say they're manufacturing a new line of waterproof clothing and they need more employees than 150 or they need to expand, they get to 150, they go build a new facility. It can be next door, as long as it's physically separated. It builds that community where everyone in that facility knows each other, has a meaningful relationship with each other. So that's really the principle that we've applied at the directorate level. They should be no more than about 150. And that allows us to do some good things. So one thing is we can have a real sense of community and culture within that directorate. Again, if you think of Tesco as a whole, it's really, really hard if we were to build one system to represent Tesco. It's also really, really hard to build one culture that represents just Tesco. Right? We have microcultures, and within a directorate, we can define a culture that 150 people can organize around pretty well. One way we do that is through having quarterly, what we call level ups. It's an entire day where we bring everyone into one location as much as we possibly can. And we do interesting things like have Martin Fowler come along and talk, which we had a couple of weeks ago. We do hackathons in Level Up. We do coding dojos. We run unconference-style sessions. We get external speakers in. It's basically a time for everyone to come out of the backlogs, out of the day job, and think and learn and get to know each other. And generally, it ends up in the pub at the end of the day as well. So Andy's now going to talk a bit about how we deliver outcomes across those directorates.
Firstly, I have to apologize for the previous photo of me. Adrian said if I could find a picture of the audience, he would put that in instead. I looked at the pictures I have of audiences watching Level Ups. It's very hard to tell the difference between a group of people concentrating and a group of people that look very bored. And I'll leave you with that. And I thought, let's go with that one instead. So anyway, delivering outcomes. So the main challenge when you get services is how do you deliver cross-functionally? So you've got outcomes that need things across multiple different things. So who's going to have the technical vision for something that uses 7 different services? Who's going to manage the program? Who's going to define what the product is? Because our product owners sit within the service teams. And how do we avoid creating software that doesn't work together? So we came up with a number of different solutions for this, and we worked our way through them. So in the spirit of failing fast or succeeding, we prototyped each one of these. So we pulled teams together, and we said, we're going to do this one in this way, see if it works. If it doesn't work, we do the next one. Maybe if that one works, we'll do the last one anyway, just to see what happens. So we shape sort as the first one. And here's a diagram that broadly explains how that works. So you have a bunch of product owners at the top, and they own a particular customer outcome. Might be registration. It might be sending out a new club card to our entire club card user base. They define their requirements, and they might have a triangle-shaped requirement, a star-shaped one, a pentagon-shaped one, and they'll put them into their backlogs. Then we get a very clever person who wears a hat, and they decide which services those requirements are needed on. And they sort them down onto the services. So all the triangle ones end up in triangle, all the pentagon ones end up in pentagon. But this gets very, very, very confusing. When you take the shapes out, which is super easy to understand, it gets complicated. So who's going to build the thing that does generating secrets to put on the new chips on the club cards? Which service does that belong on? And fairly quickly, the guy in the hat has to be so clever that we can't find anyone that clever. And we did look. And I came up short. So Shape Sorter was one we rejected early. We tried it. The contention on this person is incredible. The amount that they need to know is incredible, and they get it wrong. So, sad face.
So then we evolved and tried and experimented and again looked whether we could succeed or fail fast. So we looked out what other people were doing, and hands up if you've heard of the Spotify model. Okay, pretty much everyone in the room, unsurprising. So we looked at the core concept there of squads or product teams, cross-functional teams, if you like. And it's not rocket science, right? You give them a product that they're responsible for, and you give them the right set of people. You know, if it's a web product, you give them some front-end developers, maybe some back-end developers, maybe a UX person, a product manager, maybe some testers, and you say, right, now we're going to throw you problems, and you're going to build amazing stuff. And that's great, and it's great in the right context. And before I worked at Tesco, I was working in a digital marketing agency, and it was absolutely the right construct for us, and we evolved to it and we adopted it because every problem looked fairly similar. Every problem was building a brand website. They all need a bit of web UX. They all need some back-end integration, XYZ, so on and so forth. If you go read about the Spotify model in detail, the guys from Spotify will tell you don't just pick it up and adopt it. It's all about context, and we didn't find that it was the right context for Tesco. We don't have a linear amount of work of the same kind of organizational structure needed to achieve it. We're more weighted some months to back-end work, more weighted to front-end work in other times. So what we did do is read it, understand it, make sure we grokked the really valuable bits of it that we could adopt and feed those in, and then we came up with our own spin on it, which Andy will talk about now.
So taking the best bits of both the shape sorter and the Spotify product teams model, sad face for that one. So we came up with what we call pop-up teams. Now pop-ups are kind of play to the retail where you rent a small piece of retail real estate and sell product through rather quickly. And the idea of the product teams is we have home teams and we have pop-up. Sorry, the idea of the pop-up teams is we have home teams and pop-up teams. So to run through an example of this, we recently recarded the UK with new cards. The old cards have barcodes on, these ones have chips on them so you can pay and earn your points much faster. We had to send out tens of millions of these things. And the idea was go through our entire customer base and send everyone who we should send who wants one a new card. Now, in order to do this, it uses about 5 or 6 different services. And the way in which we decided to do it was we'd take 2 people from the identity team, we'd take 2 people from the profile team, 2 people from contact, 2 people from our loyalty systems, sit them around a desk and say, have at it, go do it. Everyone's going to work on all of the code from all of the different systems. So you'd have identity people, their home team was identity, they were working on the recard project. You'd have profile people, they were from the home team of profile, but they were working on the recard project. Sit them around a table, come up with this. They would work on each other's code, so everyone learned how each other's stuff worked. A lot of knowledge sharing, different databases, some different programming languages. They would modify the code of whatever system they needed to within that group and then submit it as a pull request. The home team would review it, make sure the quality standard was up to snuff, and that it worked with everything else, kind of regression tests. All of our systems involved in this are fully automated build, fully automated deployment, so it's quite quick to do. Now, with Club Card, when we recarded these things, who has a Club Card, by the way? Most of you, some of you.
More people know about the Spotify model.
More people knew about the Spotify model. I think our audience might be biased towards technology. Anyway, so if you look at these cards, on the edge of them, they're red. When we printed these things, when we fabricated these cards, we actually used most of the world's supply of that color of red, just to give you an idea of the scale we deal at. We had to use 5 different manufacturers of cards in order to process them this quickly. No one had done this on the scale that we had done it before. And it took a team of very dedicated people a long time to do it. So if you think about the teams involved, first thing you need to do with a customer base our size is work out who's passed away since we last checked. You don't want to send these cards out to, households where that person may no longer be with us. We have to look at things like student digs. Student digs are fascinating if you look at our data because people will register a club card when they first go to university. It might be the first time they're buying food for themselves. So they get a club card, save a bit of money, move on to their next house, lose their club card, get another one. So student digs have huge numbers of people registered there. And the last thing we want to do is send to the current occupants of that address 200 club cards. So we have to go through there and pass them all out. And, those guys sat down, because they own the systems, they don't just write software that's deployed and someone else runs it in production, going through their data, cleansing it, making sure it makes sense before sending it out. We then have to integrate with fulfillment people who print the cards. We have to talk to the identity team who generate the secrets that go on these chips so that they're very secure. And this model, it worked for us. So pop-up teams, in our context, works great. Pull people from their home teams, put them together, solve a particular problem, and then send them back to their home teams. figure out what the next problem is, pull different people from the teams, put them together, solve it, and rinse, wash, repeat is where we got to.
But it's worth acknowledging as well that it's not the solution, right? It's the current step we're on the journey of organizational design. And like, just to really drive the point home, we build organizations in the same way we build software. Fast, iteratively, experiment, try, fail fast, find what works and move on. So there are problems with pop-up teams. I consider that teams are immutable objects if we want to bring this back into a software engineering context. So every time you change a team, you take someone out, you put someone in, it's a new team, right? You go through the same forming, storming, norming, performing kind of mentality. So pop-up teams is a challenge to that. The home teams change when we form a pop-up team. So let's move one level down our granularity level now to talk about services. So if you remember, a customer at a directorate level is composed of a number of services that are broadly aligned to that customer mission. So the key concept here is that of Conway's law. Hands up if you've heard of Conway's law. Unsurprisingly, most people. It's, again, nothing new. Melvin Conway said that any organization that designs a system defined broadly will produce a design whose structure is a copy of the organization's communication structure. And here's my mea culpa. I described Dunbar submitting his stuff to Harvard Business Review. It was actually Melvin Conway. Nevertheless, a simplified version of Conway's law was given by Eric Raymond, who simply said that if you have a compiler being developed by 4 teams, you will naturally end up with a 4-pass compiler. So how is Conway's law applicable to us? And this is really about talking about the kind of software that we want to build. So Conway's law says if you have an organization structure where the main communication mechanism is command and control, being told what to do, such that everything within that structure looks the same, you'll end up with a software architecture that is probably monolithic. It's not a golden rule. It's not true in every sense, but it's generally true. So instead, if you have a communication and organization structure where the main communication is autonomy, both the granting of and the use and taking advantage of, then you end up with what might be the same actual structure, but you end up with different shapes. The component parts, the leaves of the tree, can look and feel and behave in different ways, make their own decisions, and therefore they will tend to produce a software system that is more loosely coupled, more into communication, and implemented in different shapes and different ways. And that's kind of what we want. So the interesting thing about Conway's law is you can flip it, and you can do what's called the inverse Conway manoeuvre, whereby you start off with what you want to achieve in terms of we want microservices, we want loose coupling, and you can use that to reverse engineer and arrive at a kind of organizational structure. And that's where we've got to with the concept of services. So services are the smallest thing that we can build around a certain area of responsibility based on the concepts of cohesion that Andy talked about earlier. And one of the things that we found services really useful for is tackling some of our quote-unquote legacy. So here we have a fictional, we totally didn't do this, scenario of a huge, great big monolithic system, and we've built some UX in that monolithic system, and it's serving our customers. Maybe it's serving a website that allows you to order stuff and have it delivered to your home. And sitting underneath that big monolith is something people don't often talk about when they talk about monoliths, is typically one big blob of code has one big blob of database sitting underneath it. It's very rare that your monolith will be off talking to a nicely segmented set of finely chosen, different, distributed or non-distributed, relational or NoSQL database technologies. It's generally Oracle, SQL Server, or whatever. And over time, because all of your data is a monolith, various applications will have come along and said, I want to write some of that data or read some of that data. So they'll have just gone and done that because, hey, that was the quickest way. And so now you don't know who really owns that data. You don't know who's reading it, who's writing it. Maybe if you're really lucky, they're not all using the same credentials. So by inserting services, and starting to break that, or use that cohesion principle of data and functionality to define what a service should own in the ideal world, we can start to put these services in place as an abstraction layer above that big monolithic data store. And what we can start to do is take the applications and say, for a long, arduous process, please can you stop making those JDBC calls, and please can you call this nice REST API instead? And that actually works. We've done that in practice, and it works pretty well. It's a little bit scary at the time where they go, well, this is sub-millisecond to do this read. Now you're asking me to incur the latency of an HTTP call, which at best is going to be 30 milliseconds in our environment. That's going to be a problem. How are you going to scale that? How are you going to help me do that? We get over that stuff. We work with them. We make them understand. We make them understand that it's a journey and that this is a good place to go to. And invariably, those problems don't translate into real problems in the end anyway. So we get the applications talking to the services, and now we're in a reasonably good place. Now we're in a place where actually we can start tackling this big ball of mud behind, and we can start to do this. We can start to say, now that service A has abstracted away this monolithic data store, now we can break that up, and now we can implement that data in the right kind of way. The right kind of way that makes us kind of more advantageously positioned to deal with legislation like GDPR, for instance. Right? So now all of our customer data doesn't have to be in the same place as all of our payroll data. Well, that sounds like a good thing. And we can get these applications to now start serving our customers as well, and we end up with the kind of world that we want us to be. And services, and the concept of services and teams formed around those services has been really key to helping us do this. And then the second thing, as we alluded to earlier in what Andy said about autonomy, is the idea that services are one of the primary mechanisms for the heterogeneity of our technical estate. So this is a talk from a company here to be at DevOps as a sponsor, so we have to put up a slide that shows you lots of all of the cool technology that we use. We left out the slide that shows you the slightly less cool technology. We're big. There is some of that. We still have mainframes. But just within the customer area, I can vouch for the fact that all of these technologies are in use. As Andy said earlier, we're not tied to one language. We use Java, we use C#. In this particular context, even within Java, we're not tied to one framework. Some things lend themselves well to being imperative style, and we might use Spring Boot. Some things were a very high throughput. We have high non-functional requirements, and we have a team who are more reactive thinking in how they're set up. Then we tend to use something like Vertex. We have other teams in Tesco who are using things like Lagom, for example. Database technologies or persistence technologies, we have, not shown on here, Oracle. We have SQL Server. We also have Cassandra. We have Kafka. We have Couchbase. We have Redis. We have data processing technologies like Spark. We deploy onto our own data centers. We deploy onto cloud environments as well. So finally, in our level of granularities, we're going to dive down into what I personally find one of the most interesting, because it's really what my job is, and that's about what happens within the scope of one of these services itself. So here our foundational construct goes by a variety of names, and you may have heard it as the magic number 7 plus or minus 2. You may have heard it as Miller's Law. You may have heard it as 2 pizza-sized teams, but it all boils down to the same construct, which is really about how our memory works. So here is a formula. You can't have a tech talk or a loosely aligned tech talk without a good formula. And this formula actually comes from Mythical Man Month by Fred Brooks. Hands up if you've read that book. Okay, so this is a formula of interconnectedness. So what it basically says, for any given number n, how many connections are there, possible connections are there between n? And if you start to draw that on a graph, then it looks something like this. So if on the bottom we have a number of people, let's say within a team, then the number of possible interconnections grows at quite a scary rate. If you haven't noticed, this y-axis is logarithmic. So we started off talking about Dunbar's number. If you have a team the size of what Dunbar's number says, there are nearly just over 11,000 possible relationships that exist within the people within that team. Now, Miller's law, or the magic number +7, basically boils down to the fact that our brains, again, have a working memory set, or a short-term memory limit, of about 7, give or take a couple. This exhibits itself in a number of ways in modern society. Typically, phone numbers tend to be about 7 numbers long, because that's memorable. So, where this boils down to in the terms of organizational design for building software is, what is the optimal size of a team? And we believe, and science and general theory believes, that it's in and around this number. And that's what Jeff Bezos from Amazon cited as a 2-pizza-sized team, the number of people you can feed literally with 2 pizzas. And there are good reasons for this if you think about how we work, how we do things like a daily stand-up. A daily stand-up isn't for me to stand here and tell you what I'm doing. It's actually for me to be here and absorb what everyone else in the team is doing, so that we have a shared context, a shared understanding. And I can do that, and I can remember that for about 7 or so people. So we structure our teams in that. So within a service, so service is delivered by a team, and we typically have something like this. We'll have someone at the top who doesn't do any coding because we don't trust them anymore. We'll have someone in the middle who is kind of the interface between the software engineers and the pointy head boss up here. We might have a product manager, might have a program manager, but we've got this same kind of core pattern, and it's around 8 people in size, give or take. And we might replicate that pattern within a given service. But in an ideal world, we wouldn't have to. In an ideal world, all of our domains, all of our services, which are all of these shapes, and they're all different because autonomy, would all be a team of around 8 people, and they'd all be delivered by that team, and it'd be nicely cohesive, and everything would be fantastic. But in reality, of course, not all domains are created equal. Some domains are bigger than others. So we try to strive to find the smallest divisible unit of Conway, as we call it. What is the smallest size that we can get for any given domain? And it's kind of similar to how we do user stories, right? Oh, this 20-point story, or we don't accept 20-point stories, they're too large. We won't accept it until we break it up into some nice, roughly 5-point stories. And we try to do that with our services. Get them as small as they can without forcing ourselves to have new problems. So if you take identity, for example, we log people in, we log our customers in, we manage their credentials, we manage their authentication sessions. So we have to do a load of other stuff around that. We have to detect malicious authentication attempts, or malicious sessions, or successes, and things that might lead to fraud. Should that be subdivided off, or actually, no, that's core. We can't do that well if we don't have the responsibility and the knowledge for how the credentials are managed in the first place. So we end up with this kind of fractal situation of Conway's law, as we've decided to describe it. We tried to come up with a funkier name, but we kind of failed. But essentially, everything we've talked about before, you start from scratch within the scope of one of these larger domains. So it's really a software organization within a software organization. We have a mission. We're not Tesco's mission, as we were when we started out. We're the mission of identity. But we need 36 people to deliver it. That's what we've decided. We're that size of problem. Miller's law says we can't just put all those 36 people together. There's too many interconnections. They won't gel. So we have a number of approaches we could take. The approach we've taken is to subdivide it down into 4 teams of about 8 people, applying Miller's law. But even within that scope, there are ways you can decide how you then use those 4 teams. So within identity, within my area, we've decided that those teams should act as delivery teams. They can be given a problem and given the autonomy to go solve that problem. And any identity-shaped problem can be done by any of those identity teams. Right? So it's kind of is the squad model within the scope of our bounded context. And that works reasonably well, but it throws up some challenges. And it's not the only way, and it's not even the only way that it's done in Tesco. The price service that we talked about a bit earlier is done slightly differently. They have 3 teams within the price service, and they're structured more like traditional vertical silos. And that's due to the nature of what they deliver. They have one team whose delivery mechanism is basically to put software onto our till estate. And there are over 40,000 tills in the whole of Tesco in the UK, and we're deploying software onto all of them. It's not deploying it to Amazon or deploying it to Google Cloud or our own data center. It's the biggest distributed system you could really think about. So they have a team where there's a lot of knowledge around doing that, and they've structured a team around it. They then have a team around some of their distributed systems infrastructure and a team more around their API services. So there are different ways. There's no wrong, there's no right. But it's the same kind of problem, the same kind of things we then have to think about as to how we optimize the communication of these teams within a team. So there are a few things we do to do that. Firstly, when we spoke around Conway's law, the thing about Conway's law is people always tend to, certainly I've been guilty in the past, always tending to think of it in terms of organization structures. When you read it, it's actually around communication structure. So applying that in our fractal nature here, one of the things we do is evolve how we communicate. So much like everyone else, we've gone from the world of email through to the world of things like SharePoint, through to the world of asynchronous, near real-time messaging systems such as Slack. In our case, we use a Slack alternative called Mattermost. Looks the same, feels the same, isn't the same. Not bitter, but anyway. One of the things we do is organize our channels within our identity team within Mattermost to organize how we want people to think about how we develop and build software. So we have 4 teams. I showed them earlier. Let's give them a name. They're called the red team, the green team, the yellow team, and the blue team. That is literally, we're that boring. We haven't come up with better names. We don't tend to structure our communication around red, yellow, green, and blue. What we are trying to do more is structure our communication around the services and microservices we've built that are running and deploying or being built that will serve our customers. So we've got the Club Card Secret channel, we've got the on-prem API channel, we've got the card set, which is another microservice channel. And anyone from across those teams has had to delve into one of those code bases in order to deliver an outcome, who has learned things about that particular code base, can be part of that channel and can be part of the community that forms around that microservice. Another thing we do is knowledge sharing, a lot of knowledge sharing. We never do enough knowledge sharing. It's something that I want us to do even more on. So we talked at the directorate level about how we do level up. Within our services, we do even more. We do it on a more regular basis. Level up is once a quarter. This is once every 2 weeks. So we particular one of those 4 teams, one of them might be building a solution based on Kafka. And the first time we've used Kafka and we're standing it up and we're learning how to run and operate and deploy it because DevOps, it's our responsibility. No one's going to do it for us. So they will do knowledge shares and share that. We've done ones around Apache Spark, Chef, Apogee, any technologies that we're using or we think might be useful. But we go beyond this as well. We actually have what we call Kaizen days. So 10% of the time, everyone can step away from the day job and just spend working on scratching a technical itch, making improvements, automating away some burden, that kind of thing. We spoke about homogeneity of having lots of different right tools for the job, but from an operational perspective, again, DevOps, we build it, we run it. Within our service, we have 36 people. How many people do I want on call? We have 4 teams developing 50 different microservices. I don't want one person from each team on call all of the time. We don't tend to try and have teams owning systems. We try to say identity as a whole. We own everything we build. So in order for us to be able to support that, it all might be implemented in different ways, but it has to absolutely look and feel the same. And that harks back to the things that Andy talked about around trace IDs, around consistent logging into a centralized place, consistent metrics, and that kind of thing. And then finally, I want to talk a little bit, just for a minute, on one other key organizational structure that we do within a service context. And this is the concept of a run team. And this starts to challenge a little bit the DevOps mindset approach. So in a traditional structure here, we've got 4 teams of 8 people, and we go, you build it, you run it. And they will all incur some cost to the run aspect of that, whether it be an operational issue that needs looking at, something that we need to do some infrastructure as code work on, they will incur that cost. And generally, we're pretty bad in an industry of planning for that. We might call it technical debt. We're pretty bad at planning for that in amongst shiny new features. So what we do is essentially pay a team tax. So for any given period of time, and it rotates every 2 weeks, one person from each of those teams is donated to what we call the run team. And they're taken out of their product backlog. The product manager who's running it knows that they're going to have 7 people, not 8 people. And they come out for 2 weeks, and they spend that 2 weeks on a run team. And they build and run and support and operate and automate away burden and do the kind of things that you do in that kind of environment. And that works pretty well in our bounded context of around 36 people. But we're kind of thinking, is it, so every 2 weeks you do it, maybe that ends up you do it about 3 times a year given the size of the organization. Is it actually something more specialized? Do we reach a certain size of service where actually it becomes something like what Google call site reliability engineering? Okay? And you think, if you read about SRE, and I really would encourage you to do so, they wrote a book about it. They've now open sourced the book, so you can go find it on the interwebs, use your favorite search engine, whatever that may be. You can read about SRE, and it kind of, on first read, it's like, that's horrible. That's DevOps again. That's putting brick walls in place. You've got an engineering team that builds it, and all right, we called it SRE team that runs it and operates it and gets woken up at 2 a.m. in the morning. That doesn't sound good. But if you have some of the constructs around error budgets and a laser-like focus on availability and reliability and operating away automation burden through automation, and you staff this thing by software engineers and not ops people who are lower paid for some bizarre reason, then actually it can be quite a compelling construct. So that's something that we're going to experiment with, try it, use it as a hypothesis, see where we are, see if we fail fast or see if we succeed.
So, careful. We kind of described how Tesco has gone from an organization that was delivering software in a very old-fashioned way over an 8-year period to somewhere where we can rapidly kind of try different ways of delivering software. It's supported our beliefs that we believe that you should build the software and run the software. You should run the software you build and build the software you run. It's that kind of shared kind of responsibility. So when you get woken up in the middle of the night because there's a bug, you go back the next day and make sure that gets fixed. We've described how we came to this structure and the foundations that support that belief. A lot of it's based in academic papers, Dunbar's number, Conway's law, etc., etc. But it's worked for us. We've done this. Empirically, it works for us. But as Adrian was saying, your mileage may vary. You can't take what we've done and pop it into your organization. But what you can do is take ideas from this and try them in your organization and see if they work. You have to set up the infrastructure, the organizational infrastructure, in order to experiment, write hypotheses, as Adrian was saying, around site reliability engineering. We're going to sit down and have a think about, what do we expect that to do for us? We have a hypothesis. If we do this, then we can deliver software faster. We can get higher uptime. What are the metrics on that? So design and experiment. Don't just go try lots of different things and see which ones you feel better at the end of the day. Put some metrics in place. But as we say, context is king. Spotify model works for Spotify. Pop-up teams work for us. Something else might work for your organization, but what I think is true across the board is being able to experiment with different ways of delivering software. Understanding what success is the key to getting to an optimum point for you. Thank you very much. Yes.
Right. When you moved to pop-up teams, did you move? Did they have a UX and a BA and an architect element as well?
So the question is, when we moved to pop-up teams, did we have UX BAs? We don't use business analysts. We use products, but and a UI team. Yes. So we put the UI teams, the front-end teams, as we call them. We do front-end, back-end. So we use a lot of Node.js and those kind of things. But they also have in the team specialists in HTML, specialists in UX, user journey testing, and they all sit in the same team with the services guys. Yes.
Yeah. So there's a home team. that would have those people in. There's a home team that would have back-end engineers in. A pop-up team brings those together into a cross-functional team. The key difference for us is it's typically very time-bound, and it's to deliver one thing, and then it will break apart naturally, and that's good. But those people work and kind of scrum down on that thing that they're delivering, and they all have good knowledge of that, and that knowledge then goes back into the home team, so there's the ownership of what they create. And do your reporting lines change, or do they? So that's the key thing, right? So in the Spotify model, that's where tribes and chapters and those kind of things come in, because you have this matrix structure. And certainly I found that in my previous company, we iterated, and we started off with vertical silos, and we went to feature teams, and people moved about, and every time they moved, it was a change in manager and change in context, and it was horrible. And then we kind of arrived at a Spotify-ish matrix structure. So our home teams are that stability point, right? So myself as an engineering manager, people consistently report into me. I'm looking after their career. I'm doing that kind of stuff. But they might go off and be in a pop-up team. That doesn't mean that I stop doing that stuff for them.
Aaron?
So with the pop-up team, you have something that warrants the pop-up team, right? So it's going to be something important, something that needs to be done quickly. Do you tend to pick the same kinds of people from the team? So do you end up with do you always take the
No. So the question is, with the pop-up team, do we pick the same people to be in that each time from the home teams? No, we do the opposite. We deliberately pick different people to work together so that we're transferring knowledge through, so there's no knowledge owners of particular things within those teams. It also keeps it varied. If engineers, like myself, I get bored quite quickly, so I need to do different things to keep it interesting, and we do the same for our pop-up teams. Sorry, you're first. We're out of time. Okay.
Thank you.
Thank you, everyone.